that. This is less than 80. And what we just finished and we just took a test over was multiplying out polynomials. Crazy thing about this chapter, now we're going to do the exact same thing backwards, right? So one of the first things that we learned was, like the distributive property. So like how we took this 3 and multiplied him through the parentheses. And what we're going to do now is, on this guy, is take out the greatest common factor, which is a fancy schmancy talk for the reverse distributive property. So when they say factor out, or factor this guy, there's just going to be a GCF. There's all kinds of factoring coming our way this chapter, but you see right there between those two numbers, between a 14 and a 2, there is like a common factor of 2. Like 2 is the biggest number that goes into both of those lists. So what I'm going to do is undistribute a 2. And notice this guy has an x with it, but that guy does not have an x with it, so x isn't common. So just numbers-wise, 2 is common to this guy. And then, like when you distribute, you multiply through. We're going to do the reverse of that. We're going to divide. Like 14 divided by 2 is 7. And there's an x with it, so he's going to come down. This sign is a plus. He's going to come down. And then 2 divided by 2 is a 1 in that case. And you see how I just basically undistributed a 2. That's called factor out the greatest common factor. We usually call it the GCF in that case. So if you did distribute this guy through the parentheses, you'll get what you started with. 2 times 7x is 14x, and 2 times 1 is a 2. Do you see how that's what we started with? So reverse distributive property. So let's try that again. Factor this guy. All we know how to do right now is take out the greatest common factor, aka the GCF. So what we look at is just the numbers first. And I usually pick on the smaller guy, which is 5, and see, like, is that particular number the greatest common factor? Like, that goes into both of these, and he is. Like 5 goes into 25, and 5 goes into 5, so I'm going to undistribute him. When you type this in the homework, you got to put the parentheses and all this stuff like that. So this guy's got an x, but this guy does not have an x with it, so that's not common to both terms. So do a little division. That would be a 5. 25 divided by 5 is 5, and then the x just has to come along for the ride, and 5 divided by 5 is 1. So I just undistributed a 5 from this polynomial right here, which happens to be a binomial. And if I was to distribute, I'd get back what I started with. So we just factored out the greatest common factor. 5 was the GCF. So here's another one. Ooh, all these crazy letters. We're just going to look one thing at a time. So first thing I'm going to look at is the numbers. Between a 6 and a 14, can I take a common factor out of that? And that answer is yes. I can undistribute a 2. This guy's got C's with it, but this guy does not. So C's are not common to both terms. And this guy has W's. This guy does not. So again, all I could factor out so far is a number. So then how do I figure out what's in here? Division. 6 divided by 2 is 3. C has no one to play with. Plus 14 divided by 2 is 7. And then the W has no one to play with. So how do you know you did it correct? Well, one, you could distribute through, but here's what happens. If you was to look at this red thing inside the parentheses, the greatest common factor between that is 1. Like between a 3 and a 7, there is no number that goes into both of those evenly. This only has C's, this only has W's, so like 1 is the GCF with what's left over. So that's how you know you did it correctly. So let's try this guy. Now here's a weird one, right? We got numbers, so 28 and 21. What's the GCF between those? I can factor out a 7. But you see how this has x's with it, and so does this, right? Both of these terms, by the way, there was 2 terms in all of these guys so far, has some x's with it. So here's a little trick. What do you factor out? The smallest amount of x's that you see. This is x to the 7th. This is x to the 4th. So we're going to factor out the x to the 4th in that case. And then I'm done with numbers. I'm done with x's. So I put my parenthesis, and now I do some division. 28 divided by 7 is 4. And then x to the 7th divided by x to the 4th. Remember this old guy? X to the 7th divided by x to the 4th. It was kind of like called where are there more? And would you believe that there are 3 more x's upstairs? So that would still be an x to the 3rd. And you see, if you multiplied those together, you would get x to the 7th in that case. So, wow. Plus, 21 divided by 7 is a 3. And then with our x's right here, x to the 4th, divided by x to the fourth, they like cancel each other out, so there won't be any x's left with that, which means that I did my job correctly. If you look in here, between a 4 and a 3, 1 is the biggest number that goes into both of those. This guy's got x's with it, but this guy does not have any x's with it. So I have factored out the greatest common factor, which is 7x to the fourth. 7x to the fourth goes in here, and it goes in here. So not only did it have numbers this time, it also had some x's. So let's try that again. And what a weirdo little coinkydink here that we got 28 and 21 again. So that's kind of my bad. So, but still, 7 is the number that goes into each one of those, like 7 is a factor. And then you see this dude's got some x's and this dude's got some x's. So we will factor out the smaller amount every time. So that would be x to the fourth. And then this guy does not have y's, but this one does. So y is not a factor to both terms. All I can pull out is a 7 and an x to the fourth. So it is time for the parenthesis, and it is time to divide. 28 divided by 7 is 4. X to the fifth divided by x to the fourth. I don't care that you write this off to the side. I'm just showing you where are there more x's. There is more upstairs, and isn't there one more? So you're going to have x to the first, right? Plus 21 divided by 7 is 3. X to the fourth divided by x to the fourth. Those will cancel each other out, so there won't be any x's with it. But this y to the fourth has to still be there because he didn't have anybody to play with. And the way you check, if you're not sure if you did it right, 1, see if the 1 is the GCF here, but if you was to distribute this guy back through, do you get what you started with originally? So let's try a few of these, right? Let's see what happens, and let me know if you have any questions. The GCF, greatest common factor.